Can you guys hear me? Okay, cool, thank you. This is a little bit weird for me to be with the headphones thing. So thank you all for coming. As you said, my name is Shapiro. I have done native Android and iOS development since late 2010, first in Objective-C and Java, and now in Swift and Kotlin. And if there's one thing that has really remained consistent over the years, it's the desire of developers to try to avoid repeating themselves and for businesses to desperately try to save money. And to do that, they want to figure out a way to have some kind of code shared between Android and iOS. And there have been a million ways to do this over the years, often using these thin wrappers around web views that allow your web devs to build something that looks essentially like someone crowbarred your website into an app. And there were a fair number of iterations of this idea. Most recently, this has evolved into React Native, which uses a much bigger bridge between JavaScript and native code to allow JavaScript code to easily manipulate native UI. And, well, that depends on your definition of easily. But most of these frameworks have caused reactions from native developers that range from pure horror to sarcastic derision. But there's been another style of cross-platform development that I don't think is talked about quite as much, and that's code that's cross-compiled to run natively on iOS and Android. So Xamarin actually uses C# code that's compiled straight to ARM assembly code. You can also run C++ code natively on both iOS and Android. But C++ and C# both lack a lot of the memory and type safety that are built into modern languages like Swift and Kotlin. And mobile developers in particular have come to really love that functionality. When Swift first got open source, there was even a brief moment of excitement for iOS developers where someone actually got Swift to run on the Android operating system. But that turned out a little bit more to be a mountain that was climbed because it was there than something where you could realistically use it for cross-platform development. This is still in the Swift repo, and the first question in the FAQ about Android, can I use this to build Android apps, is immediately answered with a resounding no. While you can definitely run Swift code on Android, the problem is that the Swift compiler doesn't know what the hell Java or any of the Android APIs are. So you would need to write your own wrapper to make it possible for you to actually use any Android APIs from Swift. Plausibly, there's really only two teams that could do this. Apple's Swift team isn't going to do it for a number of reasons. They've got way bigger fish to fry right now with module stability. And Apple doesn't really have a ton of incentive to devote resources to making anything work better on Android. Theoretically, if Google wanted to, they could have also made Swift APIs available to developers, but they've been very busy Kotlinifying all of their Java APIs. And that's still a lot of work, but Kotlin at least already works with the JVM, so the incentive Google has to make it work is so much stronger. And this is where a really weird but critical factor comes in, which a lot of people who aren't already working with Kotlin aren't aware of. Kotlin is not actually made by Google. It's made by JetBrains, which is the company behind many fine IDEs, all of which are based on IntelliJ, the leader of the pack when it comes to working with Java. And because they worked with Java when Kotlin was originally built, it was built to run on the Java virtual machine. They were able to create a new language that allowed better and easier interaction with Java APIs without having to completely reinvent the wheel right out of the gate. But like I said, JetBrains is not Google. They don't really have any incentives to keep Kotlin completely tied to anything existing. In fact, their incentive is to get Kotlin running in as many places as it possibly can. So with that in mind, a couple of years ago, they took a look at this compiler called LLVM, which takes an intermediate bytecode and allows it to be compiled to run on many different architectures. And it turns out that LLVM began as a graduate thesis of some guy named Chris Lattner, which he's better known to iOS developers as the creator of the Swift language. Fun fact, the LLVM compiler was Chris Lattner's master's project. This was not even for his PhD. I always feel like such a slacker when I remember that. Anyway, the folks at JetBrains looked at LLVM and thought, well, if we can generate LLVM IR bytecode from Kotlin, then we can leverage everything that LLVM does to get Kotlin to run pretty much anywhere. You know what else puts out LLVM IR? Swift. Also Objective-C, but we'll get back to that in a little bit. So JetBrains' team saw this really great opportunity to make something that would not just work consistently on anything that runs the JVM, but anything where LLVM can run code. So when they first announced Kotlin-Native and all of the theory behind it, I got really excited. The idea that I could take a language that I already knew and was, in fact, co-writing a book about, which I would be remiss if I did not shamelessly plug right now, raywenderlich.com. Anyway, I could take this language I already knew and use it across 2 platforms I already worked with to build neat stuff. And when I first tried playing with it, I was really excited, but I ran into some issues pretty quickly. The alpha versions were really poorly documented. I couldn't even get existing code that allegedly ran to work out of the box for me after fighting with it for 2 days. Then, last fall, JetBrains moved Kotlin-Native from alpha to beta, and the level of usability improved about 1,000-fold. They also added a much, much better getting started guide for multi-platform projects that can take advantage of both Kotlin-Native and Kotlin for the JVM. And I managed to get the starter tutorial working after a couple hours. I took that, turned it into a little sample app that I could play with to learn more about how interop worked and get things like actually running on both iOS and Android. But you probably can't see from the audience because the type's going to be really tiny. But I stopped working in this in about November because, I had stuff to do for work, and then the holidays showed up, and I just sort of started thinking, all right, this is really great in this little toy app, but I would really like to use this stuff in an app that actually does something. It was around this time that I saw something that quickly became one of my favorite YouTube videos ever, and it is entitled Package Thief versus Glitter Bomb Trap. This video is made by a YouTube personality named Mark Rober. Mark's home security cameras managed to catch a couple of people out on their morning walk who also decided to stop by his front porch and help themselves to one of his packages before casually walking off and enjoying the rest of their day. So of course he reported this to the police, who were like, yeah, even with the video, there's not really much we can do here. So this guy was very, very disappointed. And he thought about some of his various engineering projects, including working on the Mars rovers for 8 years, and he realized that he could, as he put it, over-engineer the crap out of a solution to this problem. So he came up with an idea for revenge. The video details the glorious process of him coming up with and testing this contraption with 4 phones on a 3D printed casing, all of them with GPS on so he could track where they were, and with data plans to upload video from their wide-angle lenses, which could capture a thief's reaction from any angle. This entire contraption was topped with a mechanism that spun around a pound of fine glitter onto the recipient when they opened the box. Oh, and for good measure, there was also a small can of fart spray on a cam that would spray it every 30 seconds. All of this was carefully disguised in a very tempting-looking package to try and entice thieves to take it. And while there were definitely some thieves who took the package, opened it, and got rid of it super quickly, some of them took a little bit longer to figure out exactly what the hell just happened to them. Again, I cannot recommend this video strongly enough. It will bring joy and over-engineering to your day. I have watched this like 1,000 times now, and I still giggle like every time. Personally, I did get to go to the Jet Propulsion Laboratory where Mark used to work once. I saw what I'm pretty sure is the landing gear from the same rover that he worked on. So if you look at the still from the video, you can actually see that thing that I took pictures of from above is right behind him. But unlike Mark, the closest I will ever get to engineering anything for NASA is wearing this t-shirt that I purchased at Target for $10. So I decided to come at this a little bit less from the utterly delightful revenge angle, and instead I thought about how we can stop porch pirate package pilfering in the first place. And this is where my absolutely amazing design skills took me. Basically the idea of a box that you could bolt to the side of your house and you could open and close remotely from your phone. And there were some other ideas in there about like maybe turning it into like a flower bed or a vegetable garden to further discourage thieves from trying to detach it from your house and run away with it. And I decided that's kind of for later, so I narrowed it down to a prototype. It's a wooden box with a deadbolt lock that can be locked and unlocked remotely using a Raspberry Pi that's controlling a servo motor. Now, once I had that idea, I had to decide what to use to build this thing. So first, I was working on what general systems, and then to see if I could get them all to work with Kotlin. So again, I knew I was going to need the Raspberry Pi with the servo motor attached, and then I would need some kind of server to handle authentication and sending commands directly to the Raspberry Pi. I'd also want to build an iOS app to operate it, and you guys know, if I'm here at droidCon, I damn well built an Android app for it. So after I did a little bit of research, I tried to see, okay, will all of these things work with Kotlin, either on the JVM or native? And it turns out the answer is yes across the board. Raspberry Pi can run the JVM or native Kotlin code. There are several server apps that run on the JVM that have strong Kotlin integration, including Spring and JetBrains' own Ktor framework. And iOS is a yes thanks to Kotlin-Native. Android, obviously, already a yes. And here I would really like to pause to thank my delightful employers at Bakken & Beck for letting me take a whole bunch of work time to build all this stuff out and learn about Kotlin-Native. If you're interested in looking at the code, which a bunch of the following examples are going to be coming from, please check out the Porch Pirate Protector repo on the Bakken & Beck GitHub. I'm going to tweet this link out after the talk as well. Now, I once again got started by following the Getting Started guide to try and make sure I got any updates that had been made to that since I tried my initial little project. And there are a few things to be aware of that aren't in there, or which you will probably run into as you try to make things work. The first is the distinction between a native project and a multi-platform project. Because when you look up the instructions for setting up most projects, you'll see that you need to add a plugin to Android Studio to get the code compiling properly. But some older repos and older sets of instructions for building native code, you'll see a different plugin recommended, the native platform versus multi-platform. It took me an absolutely stupid amount of time to figure out the difference between the two that seems really obvious in retrospect, which is that the native platform plugin is for projects that only use Kotlin Native, and the multi-platform plugin is for the thing most of us actually want to do, which is build things for multiple different environments at the same time. And if you do not use the correct one, your project basically doesn't work. The next thing to be aware of is that you are about to get in a huge fight. And in this corner, in the green and the black, is the Gradle build system and its myriad versions and options. And in this corner, in the white trunks and getting punched squarely in the face, is your sanity. Because every time you do a Gradle build of any type with a multi-platform or Kotlin Native project, you are reminded very explicitly that you are working with an experimental feature. And some things which seem like they should work out of the box, or which according to tutorials should work out of the box, just flat out don't. There was one point where I was fighting with versions of Kotlin and Gradle and Native and some libraries. Some things said it would only work with Gradle 4.7, which is no longer supported by Android Studio. Some things said it would work on 5.1. Then there were conflicting reports about whether I needed to enable a feature preview on different versions. And finally, it took me 4 hours to realize that these two lines of code were the only things that I needed to change to get my existing code working. And I got to do all of this again a few weeks later when I ran into problems integrating another library that then didn't work with Gradle 4.1. So, pro tip, use Gradle 5.1.1 and enable the Gradle metadata feature preview to make sure that you can access all of the features you need to in both Kotlin Native and a number of the libraries that it supports. Note that I make this recommendation as of today. I'll try to keep the Porch Pirate Protector repo up to date with whatever's actually working a bit more than my previous experiment. You will also be using Gradle to create the framework that you eventually link to Xcode. So you're going to use a command that you can grab from the Kotlin Native multi-platform tutorial. And this will go and it will compile a binary library for your iOS app. So Android devs are pretty comfortable running Gradle from the command line. If you've got iOS devs who are trying to do this, and you're like, what the hell is this? You can show them that in the Android Studio window, there's a little Gradle logo on the right-hand side that you can click on, and you can show the list of all of the Gradle tasks which can be run. You can double-click on any task to run it, just like you would just if you did Gradle W run whatever. Your colleagues might need to know this if they are trying to set up the iOS app, and they can't find the iOS framework in the folder where it's supposed to have been output. The next thing is to be aware of is something you've probably run into if you've ever tried to build a library and an app in the same root project, and that's that folder structure gets horrendously nested really, really quickly. When you create your multi-platform project, they generally suggest making a folder for each of the individual things you're working on at the root level of a project, and have a root level build.gradle file that covers all of the projects. And then, within your shared framework, you need to make folders for each platform you're going to support, iOS, Android, and the common code between the two, and have a build.gradle for all of those things. And if you're going to be putting things in Kotlin Native framework, you need to make sure you also have a Kotlin directory within that folder. And anything that you need to have a platform-specific implementation for, you'll need to have in that same package structure in that platform's folder that mirrors the common main folder. So that's Really annoying. Speaking of platform-specific implementations, let's get a little bit more to the fun stuff you can do with Kotlin-Native. You can, in fact, expect fun. What this means is that in your common module, you can declare that you have a function which you are expecting to have implemented per platform. And next to it, you'll see a little diamond that you can click on in order to see what the actual implementation would be per platform. And because I was hitting a server that I had running on my laptop, on the iOS simulator, I knew that I needed the localhost to be localhost. But as you all probably already know, Android is running on a separate process in an emulator, so if you want to hit localhost, you have to set up a special IP address that loops back into localhost to actually access anything running on it. So that's annoying, but once you have the expect and actual fun set up, you can go back into your common module and call your expect fun like any other function, and know that it will get the appropriate value at runtime. That's pretty neat. Once you get this up and running, you can provide those things that are trivially different per platform. And then it's time to see, how do you call all of this from both applications? And on Android, it is super easy. It's basically like any other locally developed library. You add it as a dependency in your build.gradle, you import it wherever you want to use it, call it a day. On iOS, it is a little bit more difficult. So if you remember this lovely Gradle task to pack everything up for Xcode, that generates this framework that you need to drag a reference to into your Xcode project. For those of you who have not worked with Xcode before, one of the options when you drag something in is, do you want to make a reference to this or do you want to copy it? And you do not want to copy it, because otherwise these next parts are not going to work. Then you have to add it to your framework search path so that Xcode can actually see into that build folder in order to grab the framework that's been compiled by Gradle. And then you have to add a build phrase which actually builds that framework when you build your app. Now, the Gradle task is smart enough not to rebuild things when files haven't changed, so it doesn't totally kill your build times to add this, but it does add a bit of time when everything needs to be rebuilt. And you can import this framework like any other framework you would use on iOS and use its objects and properties as you would from any other framework. Wait, did I say any other framework? I actually meant any other Objective-C framework. Oh, that's right. If you flip open that cool little framework that was cross-compiled from Kotlin and take a look at its header, you'll see that it's all heavily annotated Objective-C. Now, I'm not entirely sure why this is. My understanding is that there's some combination of needing dynamic Objective-C runtime functionality to make all of this work, and Swift not being ABI or module compatible when all of this was built. I've asked a little bit about the possibility of this header switching to Swift, and eventually I got a, we will not exclude this possibility. So we'll see in the long term, but for now, assume that you're going to be working in iOS dealing with Swift and Objective-C interops. Speaking of interoperability, there are a few gotchas. Some of them are really simple and easy to work around, like the fact that a Swift array and a Kotlin array are not the same thing. If you're looking for working with typed arrays of things in Swift, you have to use a typed list of things in Kotlin-Native code. That's not that horrible. That's just like, oh, I just use a different word. Totally fine. Things start to get a lot messier when you start working with enum classes and sealed classes. And an enum class and a Swift enum are pretty similar. Enum class, you list a number of things, and then in Kotlin, you can use a when statement to go over each case in an exhaustive way. In Swift, if this were a Swift enum, you could use a switch statement to go over each case in an exhaustive way. But when these enum classes are cross-compiled, they come out as Objective-C classes which can't override init with a bunch of static properties representing each case. Now, they do at least do you the courtesy of lowercasing the names of those properties so they don't look out of place in Objective-C or Swift. The good news is that you can still use that switch statement and its enum-like syntax with the type. The bad news is that you have to include a default case to handle potential other instance of this, even though when you try to instantiate it, it won't work. The compiler becomes aware of the fact that it can't be instantiated when you actually try to instantiate it or override an initializer, but when it's evaluating a switch statement, it has no idea. So you have to include this default case, even though it's almost certainly never going to get called, which in my opinion is really annoying. You're going to run into problems like this from time to time. Eventually, you'll be able to figure out how to get your code that runs in both iOS and Android calling into a Kotlin framework. Neat. The next question is, what do I actually want to do with this ability? What are the parts of my app that can be centralized And are those necessarily the same as the parts of my app which should be centralized? And the first question I asked myself when I started to make choices around this was, what is it that drives me absolutely bananas to write twice, because it's almost identical across both platforms? The super obvious answer is anything where the app needs to talk to the server, because ultimately what you're doing on both platforms is essentially the same. You're taking JSON from the network, you're parsing it into native models, taking the native models and then using them to output JSON, sending that to the server. And both platforms have some affordances to make this not too much work, but even with those affordances, writing this twice is kind of annoying. This was also something that JetBrains identified as a really good place to combine logic, and they added native support to their Ktor networking library. Ktor has both a server element, which I'll get back to a little bit later, and several client engines, including ones for iOS and Android. Now, there's one thing about Ktor that should be really, really cool, and instead is one of the most annoying pieces of working with Kotlin-Native code on iOS. Ktor makes really, really heavy use of coroutines. And coroutines have async await built in and many other fun synchronization handlers, and it's essentially Kotlin's language-level model for dealing with asynchronous programming. And while there is a native coroutines API available, it has one major glaring flaw. It only runs on the main thread. Now, when I heard that the native team had taken a function specifically designed to make dealing with asynchronous code easier and made it only usable on the main thread, I was a little surprised. I mean, seriously, is handling multi-threading not the entire point of having coroutines? I did a little bit of digging into the Ktor code, and I figured out that they've actually set up the coroutines on iOS to use NSURL session under the hood, which is Apple's built-in networking library. They're basically just saying, go do your thing on another thread and just tell me when you're done on the main thread. In the Android implementation, once you dig into the base implementation of the client on the JVM, they're using that implementation to kick up an experimental dispatcher to run things that's not going to be the main dispatcher. So you won't get that dreaded network on main thread exception, even if you're using that Ktor client through a shared library with Kotlin-Native. So it's not as bad as it could be, but there's still a really stark difference in terms of what you need to do to get coroutines working correctly. On Android, you just have to use an existing extension to pass a thread out of the main pool. On iOS, you have to construct a very silly coroutine dispatcher that will always be called from the main thread and always dispatches to the main thread. One thing that you might notice is that you're actually importing some stuff here from Darwin, which is the underlying Unix kernel stuff for Mac and iOS. That's not the only thing you can import. You can actually import pretty much anything from most of iOS and the Objective-C standard library into Kotlin with some overlays that the Kotlin team has generated based on existing iOS headers. It's actually kind of bonkers to be able to do this. I've only done a few things with it so far, but there's some really, really interesting possibilities in terms of centralizing UI and non-business code with this. Speaking of bonkers, there's one other thing to understand about how Kotlin-Native coroutines work, and that's the fact that when they hit something which might be needed to use on another thread, they freeze their object graph where it stands. They basically tell the Kotlin-Native memory management system, hey, nothing in this entire object graph is going to change, so you can pass it around to different threads without worrying that any of it's going to change on you. And that's also something that makes freezing a one-way operation. If you try to use something that is referenced anywhere in the frozen graph, you will get an exception about trying to access a frozen object. This is a place where I spent, and I continue to spend, an awful lot of time trying and failing to get things right. Once I finally got some of this working, some of the things that I found were that basically making new objects be the result of something instead of manipulating older objects is the way to go to work around this. This is a fundamental functional programming concept, and it turns out it actually helps with this stuff. Another thing that you want to do is to avoid calling any Kotlin object, which is essentially a singleton that holds any variables from a coroutine on iOS. When a Kotlin object is created, it is immediately frozen, and because it freezes the whole object graph, any of its variables also get frozen. So I found out that I sort of found this out because I tried to put a Ktor HTTP client as a property on an object, and all of a sudden, no matter what I did, it was causing all of these mutating a frozen object exceptions. I want to thank, there's a couple of guys from France who were running into a similar problem on the Kotlin Lang Slack who helped me out with that. They did not want to be mentioned by name, but I was like, thanks, guys. There are a couple of cheats to work around this, particularly if you need to do one-time setup of like something like passing a driver to a database that you can work with. You can avoid it, if you can try to avoid it and pass individual instances of a Kotlin object, do that instead. It will make your life a lot easier. Speaking of which, if you need to have something be mutated on the native side, try to do it on the iOS side of the fence by passing an object which represents an interface. When the code actually goes to call into the iOS object, it won't be under the control of the Kotlin object graph anymore and won't complain about mutating anything. For example, I wound up making an interface to store the user token that was returned from the server. In Swift, I made a pretty simple singleton to deal with storing the token. Now, you will note that for Kotlin-Native to be able to see this, it has to be an Objective-C annotated subclass of NSObject. Otherwise, when the interop layer tries to transform it, you'll get a crash on something trying to call a method that doesn't exist. So in this code, I slightly cheated about actually storing things to the keychain, partly to avoid dealing with like actual security code that's like gnarly C, but also to see if I could actually mutate a local variable in Swift that I wouldn't be able to in Kotlin. So here, I've got two methods which actually mutate the property. And in Kotlin, I have a singleton object which takes the secure storage passed in from each platform as a parameter. And when it actually hits the methods, which will call into that Swift object and cause mutation, this now comes back into the Swift stuff and is completely outside the coroutine's object graph, and it can mutate stuff as much as it wants. That's really neat. It's also obnoxiously difficult and unnecessarily complicated. So I want to talk about something that's a hair simpler and that will actually make your life way easier, and that is Kotlin X serialization. Kotlin's official serialization tool is amazing. It allows you to take your existing Kotlin classes, and by applying a plugin within Android Studio and annotating your classes, you're able to create JSON serializers which work across platforms. You can take a Kotlin object, serialize it, and get a string with the JSON matching the data you passed in. You can also take that same string, parse it, and get back the same type of object you passed in with the same data. This is super, super helpful when you are able to do this from client to server. You don't have to annotate to account for different field names on the client and server because they are both using the same model objects and the same parsing library. This is super, super handy. Once you've got your objects coming and going to and from the server and parsing correctly, the next thing that you want to look at is centralizing some of your business logic. Because you've already got your models, each app implements its views differently, and each platform even uses different terminology to discuss how to separate the business logic from the models and the views. On iOS, the term is model view controller, and on Android, the platform really tries to steer you towards using model view view model. And what I've found when I hear about any design pattern that I like to call an MVA pattern is what they really mean is they want you to have dumb models, dumb views, and to put your logic in anything other than a model or a view for the love of God. So I went with a popular variant of this on Android called Model View Presenter. I partly use this design because I like what it's doing, but I partly used it because one of the better guides to actually getting all of this multi-platform and native stuff to work is the official Kotlin Conf open source app, which uses an MVP architecture. The other thing that I like about it is I think it breaks down really nicely along certain types you're going to be using to make each of the model, the view, and the presenter. The model should usually be a data class since it's super lightweight and shouldn't be doing too much on its own beyond being dumb and hanging on to data. The view should simply be an interface, which will get turned into a protocol in Swift and Objective-C, which allows you to define functions or properties that you want to be implemented later. And the presenter should just be a normal class, which allows you to centralize all of your logic. A huge reason I like this pattern is because the view being a pure interface makes it really clear that the view is going to be implemented very differently on iOS and Android. And on those platforms, on iOS, a view will usually be in something called a UI view controller. On Android, it'll normally be in a fragment, although I know there are some people here in the Android community that are super against fragments. So if your name is Jake Wharton, you can change that as much as you want to. Also, if you're doing that with activities, like not a problem. I'm actually kind of looking into doing this with view models, but I haven't quite gotten it to work yet. The really nice thing about this is that when you're testing you don't actually have to have a view be something that gets drawn on the screen. It can simply be a class which implements the view's interface and which allows you to test what should theoretically be UI actions without actually needing a UI. I'm going to get back to this in a minute, but let's take a quick look at how this works in practice with logging into your account. You define the interface for a login view, the properties for the email and the password, a bunch of methods which can get called from the presenter, including varying errors, whether the submit button should be enabled, and then something that gets called when login succeeds. Then you define the presenter, which will take the view as a parameter when it's created. And it'll do any number of validation things as well, but the main thing it's going to do is actually go out to the network and hit the login endpoint. And you'll note that there are actually two methods being shown here, and that's because of coroutines. The first is actually a suspend fun, which can only be launched as part of a coroutine context. However, this isn't actually exposed to anything in the Objective-C framework because there's not really a great way to expose this whole system to Objective-C and Swift. So to access this from iOS, you need to throw a wee tiny wrapper around it, which uses the coroutines that you've set up within Kotlin-Native to actually perform the operation. Once you've defined your presenter, it's time to actually define things per platform and use it. On Android, you can use Kotlin's lazy loading to set up things when they're first called. There's also code here to pipe information about which text field is in focus to the presenter when the text field focus changes, so that you can actually have live validation of a user's input. One thing to recall is that you should not touch that in the fragment lifecycle until after onView created, because otherwise anything that you're doing with synthesized properties is just not going to work at all, and you'll get null pointer exceptions and be very sad. Then you override all of the properties and methods that are required by the interface and fill them in with things which set errors on appropriate views or perform appropriate actions. On iOS, you can also use lazy instantiation and Swift to create your presenter. And since interfaces are exposed as Objective-C protocols, you can make an extension like any other Swift protocol you'd be working with, and then you can hook up that same piping of your iOS views and navigation. Now, again, one huge benefit of this entire setup is that you can test your common code and get a great idea of how things will work on both iOS and Android if you hook up the piping correctly. You can create tests in a common test folder in your shared framework, and they will run very similar to tests that you would run anyplace else. There's even a Kotlin.test framework, so you don't even have to mess around with JUnit to run anything. You can just run the tests purely natively. And again, you can define a completely UI-free view in order to test it and see how it reacts. You can check how some test backing variables are changed rather than what's actually being drawn on the screen. And that allows you to validate whether you're doing things like validating input, getting proper errors back from that validation, and having the UI react to those changes in input way faster than you can by checking something that has actually been drawn on the screen. Now, the problem that comes with testing the common module comes when you want to try to test something that hits asynchronous code, because you need to use a coroutines method called run blocking that basically waits for all asynchronous calls within it to complete in order. And of course, this does not exist for all platforms covered by a Kotlin multi-platform project. Now, I initially thought it was an issue where Kotlin-Native didn't have this, but I was wrong. It actually doesn't work in a common project because of JavaScript. To get around this limitation, you can set up an expect fun in your common test module that essentially shadows the run blocking declaration, and then in your Android test module, just add an implementation that hands things straight through to run blocking. And again, since this works in native as well, you can use the same code in your iOS test code. And then you just need to update your common test module to use your platform-specific run blocking so that when you are running it on either platform, it uses the correct run blocking implementation. So what if you want to run these tests of your common code? So fun fact, if you just run a Gradle check on your shared module that's using everything for Kotlin multi-platform, and you look at Gradle's log bar from that test, you will see that you're actually running the Android test task on your shared library, which could be really annoying, except for the fact that Android test will also run all of your common test tests. Once that actually runs, you can get this lovely little web page that you can look at to see what's passed and what's failed. Occasionally, you will be able to see some of this stuff in Android Studio. What I found is that if you're running tests one sort of class at a time, then you can get results in Android Studio. But if you're trying to run an entire suite of tests, the only way to really see your test results at the current moment is to go to this sort of web page that gets generated. So I wanted to briefly talk about some stuff that I learned building out the Ktor server, but honestly, most of what I really learned wasn't specifically about Kotlin. I'm going to confine this to some bullet points. So firstly, as someone who has basically done no server-side development, I learned a ton about how Docker works as a way to sort of shove a bunch of Linux emulators that can talk to each other inside your computer. Then I learned a lot about the MySQL database, which I hadn't really used before, and which immediately led me to learn more about ORMs for MySQL, because working directly in SQL statements is kind of hideous. I also learned a bunch about how to store data about passwords that is not the password itself and is reasonably hard to crack. And then I also learned at what point my 4-year-old MacBook Pro would just give up and decide it did not want to computer anymore. And at a certain point, that's fair, because when you are running 2 of the biggest memory and processor hog IDEs that exist, along with their simulator and emulator, and you decide, you know what should just work really nicely is to add a big old layer of virtualized Linux on top of everything, it's going to feel like your computer is about to rage out and burn everything to the ground because it's running so hot. And with that, I want to ask, do we have time for a terrible idea? I'm seeing a thumbs up over there. Okay, cool. And now, a terrible idea, a live demo. Ah! All right. So this is the same application that's now running in an iOS simulator, an Android emulator, and then this is essentially the running tail of the Docker container. So if I go into the Android emulator and I decide I want to create an account, so let's say I'll say droid@con.it, and then I'll use a really secure password like password. And then I hit this create account button. It's going to go. You'll see it creating that actual user in there. And then you'll see that it gets into this thing. And because this little guy is available, that means, oh, there's devices available to add here. So I can say, OK, I would like to add this like 10.0.0.3. That adds the device, kicks you back to the main thing. And then you can actually go in to the device. And if it's locked, you can unlock it. And then if it's unlocked, you can lock it. And you can just do this all day, and it's super fun. And a nice thing that you can also do is, because I just created that account on Android, you can go on the iOS application. Whoop. Login button. So it goes. That's, again, going through using the pitfall thing. Get up on add device. So that's going to be a different device. And then I can also go back in. I can say, oh, I'd like to add that same 10.0.0.3, and it'll have the same name, and it'll have the same number as this first device. You can actually go in and when you first line it up, you'll actually see that same thing. Now, I don't have anything set up to like change this once I've done it, but I can say, ooh, unlock, and that would actually unlock the same device from two different things. So again, all of this is using Ktor on the server. One of the things that I'm using is some of the stuff that I'm using using SQLite on the iOS and Android apps. System data. On Android, I'm basically encrypting stuff based on the Ktor and then shoving it into shared references. On iOS, everything's going into the chain. And then on the server, again, it's using a Ktor giving up type of null safety. It is still in beta. You are going to run into a lot of brick walls. Make sure you set aside time for dusting yourself off as you head up and K4 and Kotlin-Native serialization are amazing help in terms of getting all this networking stuff running. Code routines on iOS can be really hard to wrap your head around the memory management model. Even if you're used to iOS's automatic reference counting module, which is based on Arc, at least allows you still to do things on different threads, whereas this is just like, oh, you want to do that? This is all experimental. It is also stupid amounts of fun. I have been having an absolute blast doing all of this stuff, and I'm really excited to take this and put it into a production app and sort of see, push even harder against where are the boundaries that where this is really a useful and helpful technology, and where are the places where maybe it's a better idea to do in the local application. So I hope as you go forward, you suddenly become the road runner, running directly into the painting, and leaving that trans really sadly behind to run into the wall. Thank you.